Hi guys, welcome to this set of videos. What we're going to be doing here in this set of videos, it's going to follow along with the notes where really the topic we're going to discuss here is going to be about intersecting lines. Now, what you're going to see as we sort of go through this chapter is you're going to see this common theme here coming up of what is known as a transversal. We'll get introduced to that transversal actually in the next section, the next set of videos. Really the transversal is going to be sort of that common theme that goes all the way through this chapter. But to get us started here, what we're going to do is talk about right now just intersecting lines and some really important angle relationships that we can get from intersecting lines. So let's just go ahead and jump right into this. Of course, the way we always start these sets of videos is with an essential question. Remember, the whole point to what we're doing here is to be able to answer the essential question. So when we get to the end of this set of notes in these videos, you should be able to answer this question right here. How can you find the measure of the angles formed by intersecting lines, right? And so we're going to learn some of the relationships that go along with those angles that are formed when you have intersecting lines. Now, the way that we're going to do that is by learning several new things, talking about a couple of new things, and those are going to be our objectives or our learning targets, which I've got for you right here. So the way we're going to go about doing that, students will find the measure of angles formed by intersecting lines in figures with vertical angles, complementary, and supplementary angles. So right there, I give you the three things we're going to talk about. We're going to talk about vertical angles first, then we're going to talk about complementary angles, and then we're going to talk about supplementary angles, and we'll take a look at a couple of example problems about how you can use those different angle relationships to help you solve some problems. So let's just jump right into this. Here we go. Up first, vertical angles. Let me go ahead and highlight the definition for you. Really, really important here so that we don't get confused. They are two non-adjacent. Remember, adjacent means next to each other, right? So these are going to be two angles that are not next to each other. So what we've got here is the definition for you. The two angles are vertical angles when the angles are, oh, I'm sorry, I apologize. I read that wrong. If two angles are vertical angles, then the angles are congruent. So, guys, you should remember from back in chapter 1, section 4, when we did proofs, we talked about conditional statements. So this is an if Q, then P, if P, then Q. Wrote them the wrong way. If P, then Q, conditional statement, right? And you can see it. If two angles are vertical angles, right? So if that happens, if you have two angles that are vertical angles, then Q. The conclusion is then the angles are congruent. So let's go ahead and take a look at what we mean by vertical angles. Right here we give you this nice little diagram. I've got two intersecting lines. Now, this is where we need to be, we call them vertical angles, but really what you want to do is just think about angles that are across from each other, whether that be vertically or horizontally. They're angles that are across from one another. We've got it written right down here. I'll show it to you up here in our diagram as well. What this is going to be, vertical angles are going to be angle 1 and angle 3. Those are vertical angles because they are across from each other. And what this theorem tells us is that they are congruent angles, right? So angle 1 and angle 3 are vertical angles. They are angles that are across from each other when two lines intersect. So I have two intersecting lines. Angle 1, angle 3 are across from each other. That makes them vertical angles. And therefore, the conclusion is angle 1 and angle 3 are congruent. They have to be the same angle. So angle 1 is congruent to angle 3. There's my congruent sign. Angle 3. Now, again, this is, so I don't want you to get confused. I know we call them vertical angles, but think of them as being angles that are across from each other when lines intersect, because 4 and 2 are also vertical angles. Now, I realize that they're on a horizontal axis. we're still going to call them vertical angles. Still going to call them vertical angles because the theorem still applies, right? I have two angles that are across from each other with intersecting lines. So angle 4 and angle 2 are going to be congruent. Angle 4 is congruent to angle 2. So anytime you have intersecting lines, it's going to create two pairs of vertical angles. Two pairs of vertical angles. And so what we'll do is we know that then those vertical angles are congruent. Really, really important. All right, let's go ahead and take a look at how we can use these then. We can use this vertical angle theorem to find missing angle measures. So let's go ahead and take a look at this example problem I've got for you here. What I tell you is that cross braces help keep a deck post or the deck post straight, right? So I've got these cross braces in here to help keep that deck sturdy and straight. I want you to find the measure of each angle. So here's what I tell you. I tell you this top angle up here is 146 degrees. Then you have angles 5, 6, and 7. We want to find the rest of those angles. Guys, it couldn't be more simple. Check this out. What I have is I have two intersecting lines. Right there is a line, and right there is a line. They are intersecting lines, and so they are going to create two pairs of vertical angles. I have this pair of vertical angles, and I have this pair of vertical angles. They must be congruent. They're vertical angles, they have to be congruent. So this is actually a really simple problem. We know that angle 6 is going to be equal to 146 degrees. Why? Because they're vertical angles. Right? They're vertical angles. They have to be the same measure. They have to be. That's what the vertical angle theorem says. But now how do we go about finding 5 and 7, angle 5 and 7? Well, this is going to go back to a previous section where we talked about the linear pair theorem. You should remember this one. Here's what the linear pair theorem says. The linear pair theorem says you have two adjacent angles that create a linear pair. That means the two angles sum to 180 degrees. So here's what I've got. This top angle up here, 146, plus if I were to add it to angle 7, it has to equal 180 degrees because they form a linear pair. They form a straight line. So here's what I know. I know that 146 degrees plus the measure of angle 7, whatever that is, I don't know. But I know that if I add those two angles together, 146 and angle 7, they have to sum to 180 degrees. They form a linear pair, a straight line. By definition, it's 180 degrees. So, 180 degrees. Well, now I have a really simple algebra problem that I can solve. Subtract 146 to the other side. So the measure of angle 7 is equal to 180 minus 146 degrees. I get the measure of angle 7 is equal, sorry, let me slide up just a little bit. I feel like I'm squeezing. I don't want to do that to you. So anyway, we get the measure of angle, the measure of angle 7, 180 minus 146, I get 34 degrees. All right, we're doing good. I needed to find the measure of angle 5, angle 6, and angle 7. So far, I've found the measure of angle 6. There it is right there, thanks to vertical angles, right? Because they're vertical angles. And I found the measure of angle 7, thanks to the linear pair theorem. The last one I need to find is 5, but 5 is a vertical angle with 7. So that means the measure of angle 5 is congruent to the measure of angle 7 because they're vertical angles. Right, because they're vertical angles. So what does that mean? Well, that means that the measure of angle 5 is 34 34 degrees. So the measure of angle 5 is also 34 degrees. And there we go, we found all three angles. Angle 6, angle 7, angle 5, and we did it based on that vertical angle theorem, vertical angles, and using this linear pair theorem as well, which we learned in a previous section. All right, guys, head on over to the next page of the notes. We'll look at complementary and supplementary angles and a couple of problems dealing with those angle relationships. So I'll meet you on the next page.